Hello everyone, this is Abhishek Mahanti and you are watching Padarth Vigyan. So students, in this video I will solve this question from the chapter Electric Potential. So let's get started. The question is, n identical liquid drops each raised to potential V combine to form a big drop. Find the ratio of the potential of the big drop to the potential of a single small drop. So it is given that we have n number of identical liquid drops. So identical liquid drops means the radius of each drop is same. So we have n number of identical liquid drops. Assume that small r is the radius of each small drop. Radius of each small drop. And it is given that each liquid drop is raised to a potential V. Each liquid drop is raised to a potential V. It means all the liquid drops are charged, and since they have the same radius, they must have the same charge. It means all the small drops, they carry equal amount of charge. So let small q is the charge on each small drop. Charge on each small drop. Now tell me, what will be the potential V of each small drop? V will be equal to 1 by 4 pi epsilon naught Q by R. We know this formula. If a sphere or if a spherical drop carries a charge Q and if R is the radius, then its potential is given by V equal to 1 by 4 pi epsilon naught Q by R. Means the potential on the surface is how much? V equal to 1 by 4 pi epsilon naught Q by small r. Now these n number of drops, they combine to form a big drop, and we have to find what is the potential of the big drop. So what is the volume of each small drop? Volume of each small drop will be equal to 4 by 3 pi r cube. This is the formula for the volume of a sphere. And if I will combine n number of drops, then the volume of the bigger drop will become n times of this volume. So assume that the radius of the bigger drop is equal to capital R. Radius of the bigger drop is equal to capital R. Then volume of the bigger drop is equal to n times the volume of small drop. N times the volume of small drop, because n number of small drops have combined to form the bigger drop. So in terms of this radius capital R, the volume of the bigger drop can be written as 4 by 3 pi capital R cube, and this is equal to n times 4 by 3 pi small r cube. So 4 by 3 cancels, pi cancels, so you will get capital R to the power 3 is equal to n into small r to the power 3. That implies capital R is equal to n to the power 1 by 3 into small r. So this is the relation between the radius of the bigger drop and the radius of the smaller drop. Now we have to find what is the charge on the bigger drop. Charge on the bigger drop will be equal to capital N into Q, capital N into small q, because we have n number of drops and each drop carries a charge small q. So when they are combined, the total charge on the bigger drop will be nq, and let us say this value is equal to capital Q. Capital Q is the charge on the bigger drop. Now the potential of the bigger drop, let us say it is V prime. So V prime will be equal to 1 by 4 pi epsilon naught capital Q by capital R. That implies V prime is equal to 1 by 4 pi epsilon naught. In place of capital Q, you can write n into small q divided by, in place of capital R, you can write this value n to the power 1 by 3 into small r. So that is equal to n to the power 2 by 3, 1 by 4 pi epsilon naught q by r, small q by small r. And this value, the value inside this bracket is the potential of each small drop. So I got that V dash is equal to n to the power 2 by 3 into V, where V is the potential of each small drop. So the ratio of the potential of the bigger drop to the potential of the small drop is found to be n to the power 2 by 3. So students, remember this formula. If a number of identical charged liquid drops will be combined to form a bigger drop, then the potential of the bigger drop will become n to the power 2 by 3 times of the potential of each small drop. So I hope that you have understood the solution of this question. If you have any doubt, then ask me in the comment section. Again, we'll meet in the next class. Till then, have a nice day and bye bye.